Welcome back to another fantastic Algebra 1 video. Hope you're having a good time working with radical equations. Today we're going to look at more radical equations where this time we've got radicals on both sides of the equal sign. And I think what you're going to find is it's very similar to what we were doing in our last video, and it's actually going to work out to be, I think it's just a little bit simpler than the ones that we did yesterday. So let's dive right in and take a look. For number 11, you can see here that in solving an equation, you want to end up with your variable all alone. We're going to end up with v equals something here. That's what we want. But it's under this radical, and so we've got to get rid of that. And when you're solving an algebraic equation, the way that you get rid of things or you move things is that you do the inverse operation. You do the opposite. So the opposite of a square root would be a square power. And if we do it on the left, we must also do it on the right, which we did, again, in our last concept, we were doing the same thing. So when you have a square root and a square exponent, they're going to cancel each other out. They're inverses of each other, they're opposites of each other, so they're going to cancel. So on this side, we're just left with 19 minus 2v, no more radical. And on this side, we have another radical, so they're going to cancel each other out as well, leaving us with 3v minus 21. Now that is just a basic algebraic expression or algebraic equation that we can solve to isolate v and get v equals something. So let's work on that now. I'm going to move my variables over to my left. 19 is not changing yet. And there we go. And now I'm going to move my constant over to my right. It's going to be negative 40 divided by negative 5. And these will cancel, leaving me with v equals positive 8. Now, I have to still check and see just to make sure that that's not an extraneous solution. So what I'm going to do is I'm going to use this original equation, and I'm going to plug in 8. So I would say I've got 19 minus 2 times v, and instead of v, I'm going to use 8. And that equals the square root of 3 times v, which I know is 8, minus 21. So I'm using this exact equation, but instead of v, I'm plugging in 8 to see if this actually works. So this is going to be 19 minus 16. This is going to be 24 minus 21. So I've got square root of 3 equals the square root of 3. That is true, which means v absolutely works as a solution. That one is good to go. Let's take a look at number 13. Number 13 here, okay. Here's my variable n under the radical. This is what I want to get all alone. I want n equals something. So I'm going to start peeling away the layers. And the first layer I come across is this radical. I'm going to do the inverse of that, and I'm going to square it. But if I square the left side, I must also square the right side. So here it'll cancel, leaving me with 3n minus 2 equals, I come over here to square it, and I see, look, it has a square root as well. So those are going to cancel, leaving me with just 2n. Sometimes my hand gets a little ahead of my brain and it just likes to do a whole bunch of loopies when I only want one. Okay, so that's an n, not an m. And now I'm going to go ahead and continue to solve for my variable. I only have a variable over here, so I'm going to go ahead and move my variable to this side. And I get negative 2 equals negative n. Continue on to get that n all alone. Remember, it can't even have a negative sign attached to it. It's got to be all alone. So right now I'm thinking that n equals 2, but I have to check it to make sure. So I'm going to use my original equation. I've got square root of 3 times n, which I say is 2, minus 2, equals the square root of 2 times n, which I say is 2. And notice I'm using parentheses to plug my value in. That's very important. Don't forget. All right, so let's see. We've got square root of 6 minus 2 equals the square root of 4. This becomes square root of 4 equals square root of 4, and I can simplify that to 2. So yes, this totally works. And I know for sure now that n does equal 2. Now, just so you know, I get a lot of people saying, Ms. Chiefy, do I really have to check it? Okay, I checked it in my head. I've got it in a box. Can that just be my signal to you that, yes, I checked it, it does work? The answer to that is no. you've got to prove beyond a shadow of a doubt, not just to me, but to anyone who would see your work, that this is in fact a solution, that it doesn't produce an extraneous solution, that it works. So we need to see that proof on your paper. So just so you know, as far as getting full credit for these problems, I will need to see you solve it, and I will need to see you check it. Okay, the whole way. If you only solve it and you don't check it, that's only going to be half credit. So be careful of that. I know it seems like an extra step, but it becomes more important as we move forward. Okay? All right. Why don't you pause the video, take a look at number 15, see if you can get it. Come on back when you think you've got it, and we'll compare notes. All right, how'd you do? I hope this didn't throw you off too badly. There's an X here and a K here. It was just a typo, and I'm sorry that I didn't catch that before I sent you off to do it on your own, but this should have been a K, and hopefully you just solved it as if it was. If you didn't, no problem. Anytime you see something like that, you're welcome to check with me or put a little star by it, but it was probably just a typo. So there's number 15 for now. K should equal 1, and it does in fact check out. Now let's take a look at number 17. Number 17 could get a little bit tricky if you're not careful, so pay attention to what you're doing here. We're going to square both sides. Why? Well, because I am going after that A. I want to get A equals something, because this is an algebraic expression, an algebraic equation. I want to get A equals something, and in order to get to it, I've got to break it out of this radical. So the inverse of that is a square exponent. So that's why I'm doing that. So it'll cancel over here, leaving me with A over 7. Looks a little bit like a 9, but it's an A. And then over on the right-hand side, where I did a square exponent as well, I've got another radical here. So those are going to cancel, leaving me with 90 minus 2A. Now, in solving for A, I know a lot of people get freaked out by the fraction. Please don't. Fractions are your friends. This is just division. A fraction is another way to say A divided by 7. If I want that A to be all alone, and right now it has this 7 attached, the 7 is attached with division. So I'm going to multiply, because division and multiplication are inverses of each other. If I do that, it'll cancel that 7 out, leaving my A all alone, which is what I want. But remember, if you do that on the left-hand side, if you're going to multiply by 7 on the left, you also have to multiply by 7 on the right. And we have to multiply everything by 7, not just one part. So be sure to put that in parentheses so that when you multiply, you're going to distribute to all of the parts and pieces. So let's see what happens. Our 7 cancels on the left, leaving us with A all alone. 90 times 7, 630. Negative 2 times 7 is negative 14, and A. I'm going to go ahead and move this A over to the left. And that gives me 15A equals 630. Divide by 15. Oh, geez, that's a big one. No problem. I'm just going to go off to the side and do it here. 42. So that means A equals 42. At least that's what I think. I have to plug it back in and check. Why don't you pause the video, plug it back in, see if it works out, and come on back and we'll compare notes again. How about that? Even though we had these big numbers and a fraction and all kinds of crazy looking things, it worked out to be pretty simple. Square root of 6 does in fact equal square root of 6. So A equals 42 is a good solution. I will go ahead and box that as my final answer. All right, number 19. Pause the video, see if you can take care of that one on your own, and come on back when you're ready to compare notes. All right, looks like it checks out. Square root of 8 does in fact equal square root of 8. Now we could go on to simplify that and make it 2 square root of 2, but for now we can see that they're equal, and since that was the point, was to make sure that it is true and that it does work, we can stop there. And we have in fact confirmed that n equals 5. All right, why don't you tackle the right-hand column on your own, see what you can accomplish. If you get stuck or need any help, please feel free to check out part 2 of Concept 2.